So, I am Riddhi Gohil, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Conference on Information and Communication Technology for Intelligent System. The 7th edition of this conference is being organized in hybrid mode, physical and digital. And the physical mode was held in Ahmedabad, India, 27th April yesterday. And the virtual event is being held through Zoom today. So I hope you will enjoy the knowledgeable interactive session throughout the day. In this session, we have 10 presentation and each presenter will be given 8 minutes for the presentation and 2 minutes for the question answer. So on 7 minutes, I will raise a gentle reminder to conclude our presentation. So kindly follow the time limit for the presentation. There is another request to all. Please stay connected with us till the closing remarks. And if you have any query and update, you can write me in chat box. So just before we get started, he is an associate professor in the Christ University, Bangalore. And her research interests include computational security, artificial intelligence, machine learning, data science, and big data. Her core expertise lies in computational security, artificial intelligence, and healthcare-related projects. She has presented and published several research papers in a reputed journal and conference, and has a 16 years of experience of academic and research. She is a reviewer for the InterScience Journal, Springer Nature, International Journal of System Assurance, Engineering and Management, and IEEE and also ACM conferences. So we welcome you in this session, ma'am. So I would like to invite. Yes, ma'am.
Yeah, you can proceed.
Yes. So I would like to invite our first Pa Sharma, and the paper title is Comparison of Machine Learning Approaches for Forecasting Heart Disease with PCA Dimensionality Reduction. So, ma'am, you can please start your presentation. Your voice is not audible, ma'am.
Riddhi, I think it is not audible to me too. Maybe if she is not able to speak, we can give chance to next presenter.
Okay, ma'am. Okay, then we are moving our next presenter till then. So next presenter is Jasmine, and the paper title is a hybrid image age detection approaches for the image of Toklai vegetative T clone series TV1, TV9, TV10 of Assam.
Good afternoon, everyone. Am I audible?
Yes, ma'am, you are audible.
A very warm welcome to everyone. Today, in this 7 International Conference on ICT for Intelligent System, I, along with my co-author, Dr. Ranjan Sharma, is here to present a topic that is a hybrid image age detection approach for the images of Toklai vegetative T clone series TV1, TV9, TV10 of Assam against the paper ID 227. At the very outset, I want to let you know that tea, which is one of the most widely consumed beverages in Assam, contributes to a greater extent in the production of tea. However, despite of its weather and social condition, tea is cultivated in a large scale in Assam. Toklai Assam came up with a huge collection of clones of tea, which are resistant in different climatic changes. This wide range of different clones in tea, normal tea cultivator finds it very cumbersome to identify the clone and opt for the best clone to cultivate in their field. Thus, a proper imposition of computer technology is required so that they can identify which are the different tea clones. So in this context, computer vision along with image processing, pre-processing plays a very vital role. But the question here comes that how to identify the images. Then a proposal was actually thought of that if the edges of the different T clones are being identified, then the job of identification of the various T clone series that was being proposed by Toklai Jorhat of Assam could be very easy. Then next thing it came that how to use the different edge detection technique. There are different edge detection technique. In fact, many edge detection technique are popular in them itself. In this paper, we are actually trying to focus on a hybrid edge detection approach, which actually combines the popular Kenny and Sobel edge detection technique. The hybrid approach in order to eradicate flaws in the segmented image and to get better information on the boundaries of the images of TV1, TV9, and TV10. And then further dilation morphological operation was used so that the flaws can be eradicated. Then finally, the output was actually made with a comparison with the existing Sobel, Previtt, Robert Kenny, Laplacian of Gaussian agitation technique on the basis of some parameter, that is noise level parameters such as mean square error, MSE, peak signal noise ratio, PSNR, and then SNR, that is signal noise ratio.
Your slide
For
is
this,
not moving.
is it moving, ma'am, now? I'm in the second slide now, a third slide now.
No, you are on first, don't you?
Okay, so for this purpose, data has to be collected since we are very much concentrated with that only 3 clone series, that is TV1, TV9, and TV10. So our area was being selected from Assam for the sample collection, and we selected the sample area from Jorhat, that is Kamarband tea estate, Gotanga, which is there in Jorhat of Assam. Sample size of about 2,105 was being collected, out of which 769 images were from TV1 clone series, then 850 were from TV9 series, and 486 were from TV10 series. The images were actually captured with the help of mobile camera, which was with a 64 megapixel. The samples which were captured basically during the daylight, and a white sheet was placed at the back of the sample leaf, such that the background of the leaf is not visible. This was done so as to capture images with a standard background. Further, when we collect the images,
Ma'am, can you retry the slideshow? There is no moving any slide.
now I'm in the fourth slide.
No, there is a first slide.
Is there any movement now in the slides?
No, ma'am. You can try reshare the screen.
Is the slide third number is visible now?
No, it's still first slide, ma'am.
You start presentation, then you move slide. It will proceed then only.
So will I continue or yes? Will I continue?
Yes, ma'am. You can continue.
So for this purpose, image pre-processing is further required since the images are collected from the mobile phone with a dimension of 3000 and 4000 horizontal and vertical resolution with 772 dpi. So the images are basically where in green, usually green. Since the color of the leaf it changes due to various factors like nutrient content, then climatic condition, water content, and season. So the color feature of the tea leaf thus cannot be considered for the identification process. Therefore, such color information of the image has to be removed and converted to grayscale. The digital image formed after conversion of grayscale to a binary image, it requires a proper process of segregating the digital image into an integral regions. Segmentation is basically used to establish the boundaries of the objects. This continuation of the intensity level of the pixels and similarity measurements are basically used for image segmentation. The discontinuity in the intensity values of the image is actually identified using edge detection. Now, since I have said that I'm going to use, we have in fact used two popular edge detection technique, that is Kenny and Sobel. I want to bring into notice that why these two techniques were used because when PSNR and MSc and SNR were evaluated against this edge detection technique, they showed better result. So I thought of, so we actually combined this edge detection technique from Sobel and the Kenny, then along with the incorporation of some morphological operation, that is dilation. When I want to bring to notice that why morphological operation is opted, because this is actually used for where there is a pixel value where the output is based on the comparison of the corresponding pixel value of the input with its neighbor. When there is a fit, when the operation looks for the element, it is actually fit for the neighborhood, whether the element and that hits or the intersect the structuring element. So basically there are two key operators, that is dilation and erosion. Here we have used dilation for the purpose so that the loss data can be retained. So the methodology here which is adapted in this paper is that first and foremost, Kenny edge detection operator is applied to the image, that is G1 with X, Y. The output of the step 1 is stored as G2. Then Sobel edge detection is then applied to step 2. Then this two is combined and is stored against G3. A hybrid of both the results of step 2 and step 4, that is where we have stored the output of Kenny edge detection and Sobel edge detection, is stored and is named as hybrid image. Now, further hybrid image that we have obtained from the combination of Kenny edge detection and Sobel edge detection, then a dilation is applied so that we can add some pixels on the boundaries. And then further the output is again analyzed with the SNR, PSNR, and MSc values. So the parameters that are used for this is MSc, that is mean squared error, then PSNR, that is peak signal to noise ratio, and then signal noise ratio. Parameters are basically the factors which is used to measure the performance of the algorithm. So in this paper, parameter MSc is used to see whether the estimation of the quality of the image is better or not. Then PSNR is measured in the form of the dB, where the original images and noise are the error of the distorted images. Further, SNR it is responsible for giving the ratio between the useful and the unwanted information of an image. The ratio highlights the high value with the ratio. If it's with high value, it indicates that the presence of a high amount of useful information and a low amount of unwanted background noise. So SNR is also measured in the form of decibel, that is dB. So in this experiment, in this section further, the result obtained by Sobel X operator, Sobel Y operator, Laplacian of Gaussian, Prewitt operator, Robert Cross operator, and Kenny operator is compared with the hybrid edge detection approach combined with morphological operation, that is dilation. The comparison is done on the basis of noise parameter, that is MSc, PSNR, and SNR. The images of TV1, TV9, and TV10 are considered here for the purpose of comparison. Further, in the upcoming slides, that is we have shown in a tabular format the output of the various edge detection technique that is applied on the 3 clone series of T of a sum. Then the MSc, PSNR, and SNR result of the image for TV1, TV9, and TV10 are again shown in the respective table of table 2, table 3, and table 4. This is the output of the of our experiment where when applied Kenny detection to TV1, TV9, and TV10 is shown. Then Sobel it's shown for TV1, TV9, and TV10. Laplacian it is shown for TV1, TV9, and TV10. Further, for Robert Cross, Previt is shown. Yeah, it is a big notice that from the pictorial from the output when we use using Python, then we saw that when we combine Kenny and Sobel and added and the morphological operation with dilation, then the edges were more cleared as compared to the popular edge detection techniques. Then further, when we compared with the MSc, PSNR, SNR result, the hybrid agitation technique for the Kenny and Sobel with dilation, it showed better result as compared to Kenny, LOG, Sobel Y, Sobel X, Robert Cross, and Previt. So this is the tabular output for the image of TV1. This is the output of the image TV9 for MSc, PSN, and SNR for both a hybrid hybrid Kenny, LOG, Sobel Y, Sobel X, Robert Cross, and Previt. And this is the tabular output for the TV10. The result and discussion for the entire work is that the output obtained from the Python program to calculate MSc, PSNR, and SNR for different agitation algorithms are shown above. The output shows that the MSc ranges to be from 19,000 to 24,000, then PSNR to be from 26 to 38 decibel, and SNR in negative range to be from 23 to 31. For the three clones, that is TV1, TV9, and TV10. The experiment showed that the high rate of MSc for hybrid approach of Kenny and Sobel edge detection technique with dilation in all the three images. It also showed a low value for PSNR, which indicates efficient edges. So the experiment shows that the hybrid approach of Kenny and Sobel edge detection technique with dilation with the lowest value as compared to the other techniques, that is the traditional or the most popular edge detection technique. Then SNR value of the hybrid approach of Kenny and Sobel edge detection technique with dilation also shows high value, which indicates that there is more useful information other than the unwanted data or loss. So this is the graphical representation of the various edge detection technique with the hybrid approach for TV1 T-clone series. This is for the comparison of SNR for different edge detection techniques for TV1 T-clone series where hybrid Kenny hybrid edge detection technique is with better result. And this is the
Sorry
MSc.
for the interruption, ma'am.
Yes.
So, yeah, but you are running out of the time, so please.
Yes, I'm towards the end. Okay. So this is the output for MSc, which shows that hybrid is with better output. So the conclusion derived through the entire work is that the approach used for the morphological operation dilation to add the pixel in the boundaries as the hybrid approach showed some distortion and loss of edges. Further, the hybrid approach is compared with the other traditional edge detection techniques based on the noise level, which showed better output for the hybrid approach. Thus, based on the result of the experiment and discussion, the paperwork came to a conclusion that the edge detection with hybrid approach edge detection technique showed better performance, followed by Kenny, Laplacian, Sobel Y, Sobel X, Robert, and Previt. So these are the following references which were used throughout the work. So with this, I end up. Thank you.
From where you collected data?
Yes, I collected the data from Assam, that is from Jorhat. It's a tea state where they yield the tea clone series for TV1, TV9, and TV10.
Okay. And is there any benchmark which you have considered for this?
Benchmark, pardon me?
Huh?
No, actually, benchmark in the sense, since we are here we are using only the edge direction technique. So we are actually trying to identify the edges. And since it is mentioned in their monograph of the Toklai vegetative tea clone series, that all the tea clone are very identical with their edges. So we are actually more focused on the edges, and the benchmark that we are actually trying to consider is the monograph that Jorhat Toklai Vegetative they release. So that is the thing that I want to inform. Yes,
Yeah, you can proceed to next.
thank you.
We are moving next presenter. Kedari Sethi Vishnu Sainath. And the present title is the a real-time human-computer interaction using hand gesture in OpenCV.
Hello, can you confirm the
Yes,
screen
sir.
is shared?
Yes, sir. It is visible and you are also audible.
Yeah. Uh, Hello everyone, good evening. And myself, I'm Vishnu Sainath, and my co-authors are Satvik, Ashrit and Niranjan. The paper is about a real-time human-computer interaction using hand gestures in OpenCV. And the paper ID is 219. Coming to abstract, in this paper, we apply computer vision techniques to create a virtual mouse and keyboard that can be controlled by hand gestures. Our goal is to develop a system that can recognize and translate hand gestures into actions on the computer, such as clicking, typing, and scrolling, which can improve the overall experience of the computer users. Through the implementation of hand gestures as a new means of communication, the research aims to enhance the human-computer interaction. And moving on to the introduction, nowadays, computer vision has reached its pinnacle, where a computer can identify its owner using a simple program of image processing. In this stage of development, people are using this computer vision in many aspects of day-to-day life, such as face recognition, color detection, automatic cars, and etc. So, researchers from all over the world are currently working to increase the interactivity of the devices and develop ways to operate them virtually. So, we are going to work on this computer vision for this human-computer interaction. Coming to the literature survey, the papers mentioned in this literature survey have been included in the references section in the later part of this presentation. So most of the literature survey papers are application focused. In one of the paper, the authors have proposed a deep convolution neural network to recognize the hand gestures and classify them to which gesture they're using that action. And in the other paper, the author has proposed a new ambidextrous keyboard, virtual keyboard, which can increase the time of typing in the words and letters. They proposed an algorithm such that it provides the user which word will be coming after a particular word by using the dictionaries and other means of letters and words. In the next paper, the authors have implemented an optical mouse and keyboard using hand gestures. In this process, they use their skin segmentation to segment the part of hand from the background. So such that after segmenting the hand from the background, they will be using this part of the hand to detect the gestures, and these gestures can be mapped to use the mouse or keyboard virtually. And coming to the proposed work, initially when the application starts, the first thing that happens is that it acquires an image from the camera. And when the image is processed, the person's hand in the image will be recognized. And if the person is showing the custom gesture that we have defined earlier, that gesture will be mapped to particular action and that gesture will be performed. And coming to the methodology, using this project as application, a user is able to interact with the computer without physically touching it and can control it virtually through hand gestures by using the camera to recognize the number of hands the person is using. If the user is using 2 hands, the application changes its mode to keyboard mode. it allows the user to use the keyboard virtually by typing in the keys and using the single hand. But if the person is using only one hand showing in the camera, it will be again moved into the mouse and gesture mode. Here, based on the gesture performed, it will be mapped to the particular action, and this particular action will be generated using the middleware software which we have designed to control the computer virtually. And coming to the results and discussion, as we can see, while using a single hand, we will be staying in a mouse mode or a gesture mode, where we can perform operations like scrolling, pointing the mouse to a particular point, and also clicking in the right clicks and left clicks. And while using the double-handed mode, the application changes its mode to keyboard mode, and the user can freely operate typing in keys using his hands virtually without touching the system. And we also integrated some of the gestures. These gestures can be mapped to shortcuts which we use in the day-to-day life, like opening a messaging app or opening a browser or opening recently used apps like calculators, etc. And coming to conclusion and future scope, we achieved like real-time human-computer interaction using hand gestures by implementing this virtual mouse and keyboard, along with some custom gesture mapped to certain actions. Overall, the project has shown that gestures can be effective and efficient alternative to traditional input methods. The human-computer interaction can be integrated with hand gloves in the future for some performance upgrades, which is like these gloves can be integrated with sensors, so it helps to sense the gesture perfectly. Whereas while using this approach which we have proposed, like the camera can be sometimes cannot detect the user's gesture perfectly, like in different environmental conditions and lighting conditions. And also the human computer interaction can be integrated with more adaptable and flexible ways to different users by having their particular actions for particular gestures. These are the references which we have used to conclude this project. And the previous works are on this project are like they will be first segmenting the hand area from the background, but this step is avoided in our project, and which will by this we have achieved this real-time human-computer interaction. Thank you.
What are the gestures you have considered for your project?
Like while using, as we can see here, as we, with a single hand, with a single finger up, we can use it as a mouse pointer, and with two fingers up, deciding on which finger we are closing, it will be performing that particular left click or right click, and several other gestures like we can see on the screen. These gestures are mapped to different actions like opening quickly.
What are
apps.
the limitation of your project?
Yeah, some of the limitations, as I mentioned, is the lighting conditions. Based on the lighting conditions, the camera is sometimes not able to pick up the correct gesture. This can be integrated with hand gloves with the sensors in the future.
So what is your data size?
We have not used any data set. Yeah,
for
it's
training?
real-time process. Sorry?
For training, you would have used, right?
We have been using a media pipe library. So training is not done for them. We are only recognizing these gestures, and we implemented this middleware software to virtually control the computer.
So in order to recognize, you should have some database, right?
Actually, the gestures are directly recognized based on how the points on the hands are set. Like in this particular gesture, as we can see, there are like 21 points on the hand. We are using these 21 points. we are computing how these points are kept. Using these points, we will be deciding which gesture it is mapping.
Okay, thank you.
Thank you.
Okay, thank you. So our next presenter is Rupa, and the paper title is Machine Learning for Personalized Medicine.
Is my screen visible?
Yes, ma'am.
Okay, thank you. Good evening, respected session chair and other participants. This is Rupa Fadnavis presenting a paper on the applicability of machine learning for personalized medicine. The contents of the presentation includes introduction, aims, literature review, methods, conclusion, and references. To introduce with the topic, like in recent years, there is an exponential growth in the medical data as it is maintained in the form of electronic health records. And this data can be analyzed and it can be used for predicting the diseases, predicting the treatments, and also it can be used for improving the diagnosis. Also, the machine learning has recently been applied in healthcare as machine learning algorithms have the capacity to find out the different patterns and patterns available in the data and make some inferred decisions from it, or take some do the predictions and take some decisions from it. So in my paper, like I have discussed one such healthcare application that is supposed to be the personalized medicine, and this is recently rapidly advancing field in the healthcare. Here, personalized medicine is about tailoring a treatment as individualized as the disease. Like in traditional medical treatments, what happened? They are based on one size fits all concept. Like here, the different like different patients we are considering, if they are having the similar kind of symptoms, then they are given a typical treatment. But it may happen that one or two person may patient may not respond to the treatment properly. They might be allergic to some kind of drug, some kind of component available in that drug. So this was more evident in the recent pandemic of COVID-19. Like remdesivir was given to certain patients for treating the COVID, but that was found to be harmful for some another patients. So in that scenario, the personalized medicine has got more importance. Here, implementation of this personalized medicine has potential to reduce the time expenditure, financial burden, as well as means basically it will focus on increasing the quality of life and life extension of the patients. Here, different kind of biomarkers can be used, then genomic information can be used, and based on that, the personalized medicine can be prescribed. So it will facilitate earlier disease detection, and also personalized medicine, which provides more effective treatment based on individual health data. It can be paired with the predictive analytics also. And then coming to machine learning, importance of machine learning in case for personalized medicine is that it's a branch of AI which find out the complex patterns in the data which can be used to make the decisions. And since here in personalized medicine, like the complex data sets are there, so novel techniques are required to understand that large and complex data set. So machine learning will be more useful over there. And in the literature that I've seen, like dominant research method used here was supervised learning, specifically the deep learning method, which involves estimation of risk based on similarity of symbols and genetic information. So the aim is to, like for my research, the aim is to provide or develop a personalized treatment system using supervised machine learning algorithm, which will be developed using patient medical information, and different kind of parameters will be taken into account, like the genetic information, then the symptoms, as well as comorbidities or biomarkers. So all these things are taken into account and deep learning will be applied to this. So here this treatment selection algorithm, which is based on deep algorithm, will improve the treatment and also facilitate the doctors also. So in literature review, I divided it into the three parts. The first part focuses on what is the importance of personalized medicine and what are the new technologies, recent technologies that can be used for personalized medicine. Second part basically focuses on how machine learning, which particular machine learning algorithms are used for personalized medicine. And third focuses on mostly the deep learning papers, which are based on the deep learning methods. All these means on all these papers we have seen that like what are the deep learning methods are applied that was found to be more efficient. So out of the total 23 papers, I'm discussing a few of them over here. Like in this paper, the author has brought a fact that about 2.5 lakh people die in USA each year due to the erroneous medical reports. There can be different reasons for the erroneous medical reports, which can be like diagnosis errors can be there or poor patient care can be there. So in such a case, personalized medicine can be applied. Here, multiomics data can be considered over here to have the effective or to provide the effective personalized treatment. And here author has mentioned about 10 different machine algorithms, which can be used for personalized medicine and focused on different diseases also. In machine learning for precision medicine, authors have stated that means they have told the importance of genetics and genomics in case of the precision medicine. So that factors or genetic information also need to be uh, used while predicting the treatment over there, because that will be very useful. Then regarding recent technologies like applying Internet of Things or machine learning in the healthcare, here the authors have collected the patient's data from EHRs, IoT sensor devices, that is heterogeneous sources. The data has been collected and then AI
Your
technicians.
voice is breaking in between.
Okay, ma'am.
And you need to be quick because I think you are still at literature survey. You have to
Yes.
present in 10 minutes.
Yes, yes, sure, ma'am. So machine learning techniques has been applied over there for which can improve the disease progression and or also help in disease prediction over there. So here the main thing is that the data has been collected from the different IoT devices as well as the electronic health records, and that data has been initially analyzed to find out the trends in the data. Then now this paper basically focus on the machine learning algorithm that has been used. In this paper, the author has used the genetic information of about 3,000 people, patients, and to detect the different kind of cancer. So this is a multi-class classification model. So different 9 types of classes are there. So 9 types of cancers has been predicted over there. For that, they have used the supervised machine learning models like random forest, SVM, naive Bayes, and all that. And likewise, logistic regression, KNN, and they found that
Can you go to your contribution?
ma'am, actually, this paper is based on literature review. So, okay, shall I go directly on to the result?
Yeah, so literature, we have understood what are the contribution it has, but now I want to know what is your contribution.
Okay, so basically this paper means my contribution in this paper is what the collecting the different kind of machine learning algorithm that has been applied, and then I have to choose the choose those one which are giving the best results. So right now, means this is a literature review. Right now, I have not worked on that. So this is the first phase in my PhD process, like obtaining the literature review over there. So to sum up, I may say that whatever literature I have studied over here, it consists of here the machine learning has been applied on various diseases like for predicting the personalized treatments like cancer, Alzheimer's, diabetes, heart disease, Parkinson, and Warts. And these diseases are influenced by why these diseases, because they are influenced by both genes and the number of other factors like environmental factors, lifestyle, diet, as well as the other biomarkers and comorbidity data. So we can choose in that case any of the disease over here and for predicting the personalized treatment for it. And the major methods used, machine learning methods used, broadly categorized into supervised, unsupervised, and reinforcement. And different means while studying these papers, I found that the supervised and reinforcement learning methods were found to be more effective over the unsupervised one. And basically, the deep learning methods were most efficient when applied on the data. So some the research issues and challenges identified are like machine learning, since it is used in other domains very widely, but in healthcare not so widely because of the complex nature of the medical data, scarcity of the data. And since in personalized medicine specifically, it involves a large amount of data, right from the genetic information to medical history and other biomarkers. So here the data is large in size and dimensionality. Also, it is unstructured. Maybe scans are there, scans data is there. So it here algorithms will be required which can handle the multi-dimensional data efficiently. And another challenge is in personalized medicine, it is about predicting the clinical response to the of prescribed drug to the individual patients. Since these patients can be of highly diversified profiles, and since machine learning algorithms has been used, so challenges related to model stability and interpretation are also there will also be there in that. So to conclude with, like in personalized medicine here, why this personalized medicine has been so important in this time, like here due to usage of AHR scans, high dimensional genetic testing results, here patient as well as patient vitals, there are new hurdles in efficiently using this data are imposed and which can be overcome by using the machine learning techniques. So here implementing personalized medicine will have several benefits, including less labor expense, then improved quality of life, as well as it will facilitate the doctors in taking the decisions. Also, we can incorporate the predictive analytics with this personalized medicine to offer the most successful course of treatment. So for like implementation, I'm considering the breast cancer patient data that I've collected from the NCI. We have done an MOU with the National Cancer Institute of Nagpur, and right now we are working with it. We are in the preliminary stage of collecting the data and pre-processing it. These are my references, and thank you. Your queries, please.
So Rupa, I was like in the beginning, you were telling that disease like this what COVID-19, right?
Yes.
You were giving me example of COVID-19.
Yes.
How your proposed system will be compatible with some pandemic like disease which is not known to anyone, and you will be personalizing the medication.
Actually, means basically, for a pandemic purpose, it will be different. Like, but the other diseases like cancers, in which the doctors take into for certain type of cancers, the doctors take into account the genetic information also. So, but for pandemic, it may not be that much useful because there we do not take into account the genetic information, and rather that remdesivir was for pandemic COVID-19. Remdesivir or other tocilizumab were not the prescribed ones. They were just the trials because no other option was available. But when we consider here personalized medicine for a certain known diseases like cancers, so in cancers, like whenever for certain type of cancers like lung cancers, they consider the genomic data for certain cases. So in such case, personalized medicine will be useful.
So I think you have to be careful while taking this into presentation, that pandemic. You should not take that example at all then.
It is just to show like what is okay. Fine, ma'am. I'll take care. Like that particular example.
Another thing is you have taken cancer data, right? So
Yes.
what are the parameters you would be considering for personalization of cancer medication? What are the
Uh,
parameters you will be considering?
right now they have given us the patient's data, means for initial basis they have given only the 100 patients data, on which we have regular the details like uh, whatever the case history is there. So that parameters are available apart from the different biomarkers. Like at every stage, what is the means what is the type of cancer has been developed, and it is at which stage, and other biomarkers, then their locations where they are located, and this kind of information has been provided. Right now they have also not provided the genetic information, but they in course of time they'll be providing it us.
What are those biomarkers?
Blood pressure and the sugar level and all these are supposed to be the biomarkers over there.
Okay, thank you.
Thank you, ma'am.
Okay, thank you. So, Shilpa Sharma, are you ready for the presentation now?
Yes, ma'am. Am I audible?
Yes, now you are audible.
Okay, thank you, ma'am. I am sharing a screen. Is my PPTs are visible?
Yes, ma'am, it is visible.
Okay, thank you, ma'am, for the confirmation. Good evening, everyone. Today, my presentation on a comparison of a machine learning approaches forecasting heart disease with a PCA dimensionality reduction. These are the content of my presentation. Abstract. This study aimed to investigate feature reduction technique, principal component analysis, and compare the predictive performance of the different machine learning classifier to diagnose the coronary heart disease. Literature review. During my literature review, I analyzed that the different machine learning algorithms has been used in a recent time forecasting the heart disease with a different degree of precision, and they also achieve the good accuracy. And you can also see that these are the some papers that I have showed, that is I am comparing for my research, and you can see here that the gap of this paper, some achieve the low accuracy and some of the paper not use the feature reduction technique that will be affect their performance of the model. Data set. There are two type of data set I have used in my research. First one is UCI data set and second one is Framingham data set. And both data set are freely available in a Kaggle website. And the UCI data set is the combination of a 4 data set. And the number of features that affect the heart disease, coronary heart disease in a UCI data set are the 14. And the Framingham data set consists of 15 features. And the sample size of the UCI dataset is 1020 and the Framingham dataset size is 4241. And I found that the UCI dataset contain no missing value, but the Framingham have some missing values. So that we will reduce in the pre-processing step. And UCI dataset give the information to predict the patient have a coronary heart disease or not. And the Framingham dataset give the information about the 10-year risk of coronary heart disease. And these are the features of UCI dataset, 14 features, and the num last attribute, that is the num, that indicate the information that the patient have a coronary heart disease or not. And these are the Framingham dataset features that I have used. And the last target value give the information about that the 10-year risk patient have or not. And these are the different types of algorithm I used in my work. First one is classification algorithm and second one is the reduction technique. And a classification algorithm I have used for the prediction of the disease, and the reduction technique, that is the PCA, I used for the extraction of relevant features from the given features in the UCI dataset and Framingham dataset. And I have used the 7 classification algorithm, and at the end I compared the performance of these classifiers. This is the proposed work, and firstly I collect the data set, and I have did the 2 experiment. First experiment on the UCI data set, and the second experiment on the Framingham data set. And the steps of the further steps of the implementation are the same. Data pre-processing. In a data pre-processing, I remove the missing values from the Framingham data set. Then after that, I apply the scaling standardization to standardize the data, so that the every feature get the equally preference. And here you can see that this is the attribute correlation. After scaling the data, I find out the heat map of the features. This indicate the relationship between the feature. Dark color represent the highest relationship. On the left hand side, you can see this is the figure representation of UCI dataset features, and the right hand side figure represent the Framingham dataset features. After getting the relationship, how the features are related to each other, after that I apply the PCA, and before applying the PCA, I find out the number of component for the both data set. And you can see here that this graph represent that the number the variance between the features going increasing as the number of component is increasing. So I set the 11 PCA component for the Framingham data set, and the 9 component for the UCI dataset. And after applying the PCA, then split the data into a training data and the testing data by using the 5-fold cross validation. And then apply the 7 classifier to predict the disease. And after applying the classifier, then we measure the performance of the classifiers. And for measuring the performance of classifier, I used these parameters: accuracy, ROC, chart precision, recall, and F1 score. Next is the result and the discussion. In this graph, you can see here the blue bar lines represent the UCI classifier accuracy, and the gray lines represent the Framingham dataset classifier accuracy. And you can see here that the XGBoost and the random forest get the highest accuracy in a case of UCI, and the XGBoost and the SVM get the 85% accuracy in a case of Framingham dataset. On behalf of accuracy, I also calculate the recall, F1 score, precision, because they are also an important parameter for the performance measuring. So when we compare the SVM and the XGBoost performance in a case of left-hand side figure represent the Framingham dataset performance, and in a figure A, the SVM XGBoost have the same accuracy, but the value of the F1 score is the highest in case of XGBoost. So we conclude that the XGBoost is the better classifier in case of Framingham dataset. And on the another hand, the B figure represent the UCI dataset classifier performance, where we get the XGBoost have the highest value in all the parameters.
I'm sorry for the
That's
question.
yes, ma'am.
Yeah, but you have only 1 minute left.
Okay, ma'am. This is the ROC curve representation of a different classifier at the each fold of the cross validation. And here we can see that the highest AOC curve is achieved by the random forest, that is the 1.0. And this is for the Framingham data set, that is the AOC curve achieved by the SVM and the Navy bias, that is the 0.72. And this is the precision recall curve representation in which the random forest achieves 0.34 highest AOC curve. And the next is the highest precision recall curve achieved by the random forest on the UCI data set, that is the 1.00. And this is the graph represent the comparison of my model with the another model on the UCI data set, and it indicate that our model achieved the highest accuracy, that is the 98.43. And the conclusion of the conclusion is that our finding indicate the PC improve the classify performance, and this model can significantly improve the decision making in coronary heart disease prediction. And in future we can increase the model performance by adding the more technologies or by using deep learning algorithms. And we can also extend the data set, and we can also use these method for another disease. And these are the references. Thank you. Any query?
Can you go to first slide?
Yes, ma'am.
I can't see the title slide.
Yes, ma'am.
Okay. So what are the parameters you initially considered collected for the disease identification?
Yes, ma'am. I have used the two data set, UCI data set and the Framingham data set. And for the UCI data set, initially these are the 14 attributes that I have used. And after applying the PCA with the 9 component, I reduced these features. And
After, yeah.
and in a case of Framingham data set, initially I have a 15 attribute that will be reduced by using the PCA 11 components.
So on what basis you have considered this 11 parameters?
Yes, ma'am.
On what basis have you selected this 11 parameters?
Yes, ma'am. I have selected on this PCA component. This graph you here you see on the basis of highest variance between the attributes. Here you can see that the variance is increasing with the number of component. And I have did the experiment on a different component after the 8, 9, 10, 11. But I get that these component 11 and 9 and the other parameters are not affected. They give the highest result on the 11th and the 9th component. That is the reason that I have selected.
So there are many already existing models. How your model is better than their models?
My model, as I suggested, if I compare my model with the suggested model, it gives the highest accuracies and precision and recall. And it also some as I mentioned in the literature review, some have not used the reduction technique, and they have that is the reason behind that they have a low achieved accuracy. And by using reduction technique, I identified the performance of the model is increased.
Okay, thank you.
Thank you, ma'am.
Okay, thank you.
Thank
So,
you, ma'am.
there is. So next presenter is Harsh Bihani, and the paper title is Automatic Music Melody Generation Using LSTM and Markov Chain Model.
Yes, ma'am. Am I audible?
Yes, sir.
Okay. Is my PPT visible?
Yes, sir, it is visible.
Okay. So, very good evening, everyone. My name is Harsh Biani, and I am here to present on the topic automatic music melody generation using LSTM and Marco Chain model on behalf of our group. So, these are the authors. Coming to the introduction, music is one of the popular arts and therapy in many ways. Composers try to create new music every now and then. But music composition is a complex and time-consuming task which requires high level of skill and creativity. We studied and implemented two methods to generate melodies automatically. The first one is deep learning based LSTM and other one is probabilistic model Marco chain. We will present about the implementation of these models. We will also discuss the applications of these experiments in real life scenarios. So long short-term memory, LSTM. What is LSTM? LSTM is a type of recurrent neural network architecture which is used for processing sequential data. LSTM networks incorporate memory cells and gating mechanisms that allow to selectively retrain or discard the information over time. So this helps LSTM model to learn long-term dependencies in data. And as melodies have the long-term structural patterns, LSTM is capable of capturing them. So LSTM can be trained on melody samples and predict the next notes in sequence based on previous notes and it has seen and generate the new melodies. So here we can see this is a piece of music and we can notice that there are similar structural patterns that are repeating again and again. So this is the design of LSTM model. So the very first step, as we can see here, is pre-processing and training of the data. And then we input some sample music as set of notes and new sequence of notes result and the generated output is the new sequence of notes resulting in melody which will be generated and this will go on and on. So, Marco chain. What is Marco chain? Marco chain is a mathematical model used to represent a system that transitions between different states with a certain probability. In context of melody generation, it can be used to compute the probability of transitioning between different musical notes and chords. So you can select an initial note that is a random note and generate new melodies considering the probabilities based on the frequency of transition from that current note to all the possible notes in the data. So Marco chain takes only current note into consideration and not the previous sequence of notes. This is the design of Marco chain. Let us consider two notes named E and A. So here we can see that the probability of note A to be predicted after note E is 0.7, whereas note E itself has a probability of 0.3 to be predicted after E. Similarly, the probability of note E to be predicted after note A is 0.4, and whereas note A itself has a probability of 0.6. So this is the basic model how Marco chain model works on probabilities. So LSTM versus Marco chains. LSTM can generate more complex and structured melodies compared to the Marco chains that produce a little bit simpler melodies simpler and repetitive melodies compared to LSTM. So LSTM considers previous sequence of notes, whereas Marco chain considers only the current note. LSTM, uh, in the case of LSTM, we require a large data set to train, and thus it makes the LSTM slower and it takes a lot of time. Whereas in the Marco chain, the data set is smaller, usually a one song, and it is comparatively faster. And LSTM mimics the style of particular genre because there is an extensive training process going for LSTM, and it can repeat the styles and genre, whereas Marco chain is more generalized and do not capture the specific styles. Coming to the applications, there can be various applications of automatic music melody generation. A few of them are listed here, such as in music composition, automated melodies can be used by musicians, composers, and producers to create new songs and tracks. In film soundtracks, this technology can be used to create original scores for the entertainment purpose, like movies, TV shows, and other forms of media. Coming to the video games, this generated music can create immersive experience for gamers by using them for video game soundtracks. And the advertisers advertisers can also use it for creating music for commercials and other promotional content. Future scope. So in the future, this model that generates automatic music generation can be more integrated with other areas of computer science, such as NLP and image recognition and speech synthesis. This integration can allow for creation of more complex and dynamic pieces of music, considering the different contexts and environments, and it can adapt various environments. So along with generating new music, we can use the sentiment analysis. So the user, we can experiment on the moods of the user, and we can generate different type of music which reflects various moods like happy, sad, emotional, etc. Concluding the PPT, in conclusion, automatic music melody generation is a promising area of research that has been significant research in recent years. And generated music exhibit musical qualities of rhythm, harmony, and melody. This has the potential to revolutionize music industry by making music composition more efficient and accessible. However, we have to come over many limitations, such as lack of emotional depth and variation. Now, we require more research for advancement in music generation to create more diverse and creative music melody. Thank you.
So actually, in between, I got disconnected. Can you go to the work which you have done for music, automatic music generation?
Yes, we have discussed about the two models. We worked on the two models to compare between them, LSTM and Markov chain models. So where
Which
shall I
one
start
is
from?
performing better?
Yes, the LSTM, both has its advantages. Like LSTM is definitely performing better because it is a deep learning model. So it requires a lot of training data set. So we pass a large amount of data set. So it requires a large time, and it studies the data set and creates the music according to that. But the Markov chain has an advantage. Like suppose if we pass the Western music data set for the LSTM, it will study only that and create music according to the Western music. But if we take the Markov chain model into the consideration, it's a probabilistic model. So suppose we pass a particular song in it, so it will take a random note from it, any song, Western, Indian, German. And
so what is the data set you have used for training your deep learning model?
Yes, for deep learning model, we have used the humdrum dataset, German folk songs humdrum dataset. It is a kern file, which we later converted into the MIDI file.
Okay. Okay, thank you.
Thank you, ma'am.
Okay, thank you, Harsh. So next presenter is Simring Fatima Sayed, and the paper title is Machine Learning Approaches for Brinjal Leaf Disease Detection.
Yes. Good evening. Good evening, ICTIS. Good evening, Samiksha ma'am. Good evening, everyone. Ma'am, can you give me the presentation slides? Okay.
Sorry, ma'am.
Nothing, ma'am. Actually, at the first, I did not got the presentation slides. Now, hope am I audible and visible? Sorry. Am I audible and my...
Yes,
Hello?
yes, ma'am.
Is my screen is visible, ma'am, to you?
Yes, it is visible.
Yes, ma'am. Okay. So, my topic is about machine learning approaches for the brinjal leaf disease detection. First of all, I would like to thank to ICTIS for giving me the opportunity to make the presentation of these various kind of brinjal leaf diseases that are currently occur in the current scenario in the world. So now these are the contents that I am going to deal with in this presentation. So first of all, I would like to introduce that. Hello.
Yes, please go ahead, but I can't see your PPT. Your PPT sharing is not visible.
Yes, ma'am. One second, I will share. Now, is it visible, ma'am?
I can't see it is coming. Maybe some network issue at your end.
Everything is fine over here, ma'am. I will once resume my share.
Riddhi, are you able to see the PPT?
No, ma'am, right now not visible.
One
Hmm.
second. I will stop sharing and I will share screen once again. Now, ma'am?
Yes, it is visible, ma'am.
Yes, it is.
Thank God, ma'am. So first of all, good evening, everyone. Good evening. Your name, ma'am? One second.
Good evening. You proceed with your presentation, please.
Yes, ma'am. First of all, I would like to thank ICTIS for giving me this opportunity to help me to explore, to giving me the opportunity to explain about this brinjal leaf disease detection. So the thing I have covered in my PPT is about the introduction, the objectives I have done, and the types of brinjal leaf diseases, and the previous work, proposed methodology, machine learning techniques that I have implemented, and the results, and the conclusion, and the references. So first of all, I would like to introduce this since the brinjal plays a vital role in every human life, and since I'm studying a lovely professional university of Punjab, so from in that state, most of the people loves to eat brinjal, and the current scenario is the brinjal leaves are also keep on increasing day by day, and mostly the brinjal helpful in protecting from cancer, in fighting the cancer and different kinds of cancer that is occurs to human. But still, currently people, as the scenario keep on going, that the people are unable to protect the agriculture family. Instead, they keep on looking for their profits as for the development of the industries and everything. They just keep on increases the deforestation of the agricultural land. So by which the diseases are keep on increasing. Since we have to respect the agriculture family, through the agriculture only we are surviving. So for these to recognize the diseases, I have a, I have a, we have to use some necessary and the precaution advanced techniques to recognize the brinjal leaf disease. So my objective in this present work is to study the various brinjal leaf diseases for the careful detection of disease, to predict and classify the diseases through the SVM, random forest, and VGG16. Since these SVM, these machine learning techniques have always proved to differentiate healthy and unhealthy leaf, since our proposed model is suitable only to the random forest classifier, since it is only has able to achieve the highest accuracy and also helpful in overfitting and underfitting methods. So these are through these type of disease, brinjal leaf diseases only. These are the research gap of my work that I have implemented in my work. So for that, I have gone through 60 papers in which in most of the people has been benefited with the various kind for their various respective area. They got benefited to the machine learning algorithm. So they have achieved highest accuracy in their respective areas in the respective years. So in my proposed methodology, what I have did is I have collected the data from the Hawaii data set, Hawaii State University data set mostly, and I have analyzed the data. I have applied the pre-processing technique, and later I have construct the models for VGG16, random forest, and SVM, through which they have calculated the various accuracies, different accuracy, and classified it. So upon that, I have selected upon the SVM, random forest, and VGC16. Random forest had predicted the highest accuracy. So I have calculated consider the final output. Since machine learning techniques and algorithms, as the times have changed, these machine learning techniques have always been updated and came into existence. So they have helpful in various areas. In not only in my brinjal leaf, it has also been benefited in stomach abnormalities, monkeypox diseases, etc., etc. So by performing the live data, I have analyzed it. So the feature is that what kind of mentioned disease it occurred in the brinjal leaf. So we have used these machine learning methods such as random forest classify VGG16 SVM over the data. So these are the results in which first of all it has categorized, and later I have by constructing the model, I have got the accuracies to the VGG16 first and SVM second and random forest, in which comparatively random forest I have got higher 98.7%, which is capable for the brinjal leaf disease comparatively to that of SVM and VGG16. So finally, this is the comparison of the implemented technique. So as for the coming eventually, I could tell that since the number of leaf diseases are increasing daily, we have the technique is always required to classify the disease using machine learning approaches, and therefore we have implemented the machine learning technique by combining three different algorithms. So since random forest can not randomly, it is helpful even for the large data or for any kind of data, it is helpful, and it performs higher accuracy always rather than comparatively VGG16 or SVM. So in future, the random forest help farmers to recognize the disease at the early stage of its life. And the future scope of this project, I'm thinking, is to implement through not only machine learning, but as well as robotics and some more applications that is existable, I can prefer. So these are the references that has motivated me to do this work. And thank you. Any queries?
What was your data size?
Data size was around 2,600, ma'am.
It was real-time data?
From the Hawaii data set, ma'am. I have derived some from Hawaii data set and as well as from the agriculture land of the LPU, ma'am.
Okay, so your model accuracy percentage?
98.6%, ma'am, for the training, and the validation 97%, ma'am.
Okay, so how you divided data?
Ma'am, actually, I have performed on the Google Colab. In that I have imported the libraries, split folders. So it uses to split the data set accordingly.
Okay, thank you.
Thank you so much, ma'am. Thanks for the opportunity that you have provided me. I'll be very thankful for you people.
Yeah, thank you. So next presenter is a Figo, and the paper title is a Mental Wellness Mind Matters.
Hello, am I audible?
Yes, sir.
Yeah, 1 minute, I'm sharing my screen. So is my PPT visible?
Yeah, yes, sir. It is visible.
Okay. Yeah. So good evening to everyone present here. I am Figo Cardozo, and my co-authors are Om Vadat, Vansh Pahuja, Rishti Sambedi, and our mentor, Dr. Grisha Bhatia ma'am. So this is the agenda for today. I have the contents of my PPT include introduction, comparison with the existing system, and so on. So I would like to start by introducing my topic. So we all might have gone through a phase in our lives where we felt helpless, restless, and were not able to understand what to do. It is a topic that can evoke emotions of fear, sadness, hopelessness, but also strength, resilience, and hope. It is a topic that can be challenging to talk about, but it is also one that deserves our care and attention. We as a group wanted to create a safe space where users can share their experiences, learn from one another, and work towards promoting better mental health for ourselves and those around us. Through this paper, we aim to shed light on the complexities of mental health, the challenges, and provide practical tools and resources to support individuals in their mental health journey. So we have done comparison with the existing systems. What we found out when comparing the existing systems was there's no way for a patient or a user to identify a psychologist or to book and schedule an appointment with a psychologist. There was no means for scheduling an online appointment with the psychologist, and there was no proper instructions given to the user like what to do after taking the screening test. So the methodology of our project is we have divided our project into 5 modules, that is detection, classification, evaluation, recommendation, and awareness. In detection, the patient has to take the screening test. In the classification, we classify the patient into various categories. Evaluation is done by report generation, that is the psychologist will generate a report. Recommendation is done by appointment scheduling, and the awareness is the blog where users can come and read about mental health and related issues. So as you can see, this is the block diagram. As you can see, there are 3 users, that is a patient, a psychologist, and an admin. The patient has to first register and log into the website. Then he has to take the screening test, after which he can schedule an appointment with the psychologist based on his needs, and he can go through the awareness blog to read about mental health related posts. As you can see, there's a psychologist video as well. The psychologist will be provided with the login credentials by us, and they have to log in, after which they can view the screening results. That is the data that the user has filled out, that is given that they have taken screening test, and whatever they have responded is visible to the psychologist. Based on that, the psychologist will generate a screening report, and which will be sent to the user, that is the patient, via mail. The psychologist will also be able to view the scheduled appointments, that is the users who have scheduled appointments with them, and the psychologist can go through the graphs that we have provided. The graphs are based on the data that is being submitted by the user. Then there's an admin. The admin has the responsibility for creating and sending the report that is being sent by the psychologist to them. They can confirm the appointments that is being requested by the patients, and they have to monitor the blog, that whether the content being posted on the blog is appropriate or not. So I would like to show you the demo of our project. Just a second. So this is our website. As you can see, there is a screening, appointment, and awareness modules. If you clicked on the screening, the user is asked to first register. I've already registered, so I will directly log in over here. For the registration purpose, we have added OTP verification as well. Then the user has to take the screening test. This is the basic screening test. The user has to answer certain questions. I'm randomly answering these questions for now. So there are 13 questions. And once submitted, the screen has been displayed to the user, where then that a psychologist will go through their responses and will get back to them within 24 hours. The user is allowed to make an appointment. So they can make an appointment from there, or they can make an appointment from the home page as well. For now, they have an option to track their appointments as well. For now, I'd created an appointment already. So there's an option to reschedule the appointment. So if I want to reschedule the appointment, I can click on the date that I want to reschedule it to. For example, I'm giving tomorrow's date and the time accordingly. And they can select 2 modes, that is online and offline. If they select the online mode, they will be sent a link of the Zoom meeting, that is the registration link, on which they will have to join for their session with the psychologist. So this is scheduled, and as you can see, just yeah, so you can see that a mail has been sent regarding the confirmation of the appointment. Then we have created a psychologist view as well. I've already logged into it, and where they can view the screening data as well as the results. So the screening data will be shown here, like the questions have been given here and the responses. So now I recently filled out a response over here. Also, they can view the screening data results. That is, we have provided graphs for them regarding like what the users have been responded. So these graphs show that how many users have been responded for a certain question, like how many out of the total users on the website, how many have responded excellent, how many have responded good, etc. So these graphs indicate to the psychologist like their patients, how their patients are responding to their treatment basically. Also, the psychologist can go through their appointments as well. So now there are 2 appointments scheduled. Yeah. So the psychologist will log out as well. So yeah, this was our paper. I would like to conclude by saying, just a second. So I would like to say that our main aim behind this project was to create a safe space for users or patients to deal with their mental health. And as mental health is not just it's not just a stigma, but it is a real disease that people should treat it more seriously and not take it lightly. So these are the references that we have used during our project. Thank you.
Can you go to first your title slide?
Yes, ma'am.
Okay, so with this title, I'm not able to make out anywhere that whether you are making a web project or you are going to build a model for the psychologist.
Yes, ma'am. Actually, we have built a website for now. In this paper, we have not included the model, but further we had created the model. So while writing this paper, we had finished only half of the project, which we are working on. So this paper just includes that part, which is a web app, which consists of screening test and appointment scheduling, as well as a blog.
I think you should, if your model is ready, you should include model in this paper because it is a Springer conference and only this web based interface creation. I don't think so. When it go for second round of scrutiny from Scopus, they may question us.
Okay, ma'am.
So,
but we have the model also ready. So yeah,
it is better if you add the model. And another thing which I want to know is you are collecting patients' data, okay, individual patients' data. What kind of security you are providing to the data which you are collecting? How you are securing data?
Yes,
because
ma'am.
it is
Actually,
very sensitive data.
Yes, ma'am. Yes, ma'am. So this project we have built in collaboration with a psychologist named Shanila Garrett, ma'am, who is a sports psychologist at Lakshya Shooting Club. So everything is being monitored by her. So all this data will goes to her. For now, it is not been deployed yet, but once it will be deployed, the data is being handled by her. We have also taken a consent form. I will like to show you that. Just a second, ma'am. So we have been given a consent form to the users as well, where they have to sign it, they have to agree to it. So this is the consent form. This is also being provided by our psychologist in collaboration with whom we are working for.
Okay, thank you.
Thank you, ma'am.
Okay, thank you. And the next presenter is Sagar Kumbari. And the paper title is Real-Time Pedestrian Detection.
Good evening, everyone. Is my screen visible?
Yes, sir.
Yes, okay. So good evening to everyone present here. So my paper title is Real-Time Pedestrian Detection. So so coming to the introduction, pedestrian detection is a very important task in computer vision, which has a notable research and applications in autonomous vehicles and various fields, video surveillance, security cameras, and traffic management. Next, coming to the motivation behind this is the study can improve the performance of pedestrian detection in real time. It can reduce the inference time that can boost the detections in autonomous vehicles and video surveillance cameras. Then reduce the inference time can help in traffic management and marketing areas. So the need for this is, as we can see, autonomous vehicles are in the boom now. So where autonomous vehicles, video surveillance has become a boom, where we can deploy these real-time pedestrian detection models. So the problem statement here we are testing is in this ongoing study, we will use a Raspberry Pi to test and compare various real-time object detection algorithms to see how effective they are at recognizing pedestrians. By employing this strategy, we will be able to contrast model outputs in the context of edge devices. So Raspberry Pi is one of the edge devices that we will be using to test the different object pedestrian detection models. So our objective here is to test that in a Raspberry Pi and to check and to test 4 different models on Raspberry Pi. Inference in normal light conditions and noticing the accuracy, inference in the low light conditions and noticing the accuracy, inference in the inference of the pedestrian along the distances. Like we will be varying the distances of the pedestrians and then seeing how well we can detect the pedestrian. So for literature survey, I started with all the object detection methods where we started with simple image processing object detection methods, which are SVM and Viola Jones object detection. These were very small object detection because they were mostly based on image processing techniques. Next is convolution neural networks was a very big change in the object detection. What happened is the convolution neural network is very efficient in object detection, where faster RCN and mask RCN and were very good and performed very well on MS Coco data sets. And coming to next convolution neural network, there were deep neural networks. Some of the deep neural networks were dense-net, SqueezeNet. These were very good in achieving accuracy, but they were very computationally expensive, like huge number of parameters and huge time cost. And next is like YOLO models. Like YOLO models are very they are known for single shot detectors because YOLO SST which take less time in detecting objects. Next is like mobile net and all that. They're very accurate in detecting objects with a very less speed. And next were lightweight models like TensorFlow Lite. They were very lightweight models which achieved good accuracy, comparable accuracy with less speed. Next, from the literature survey, I selected efficient date, tiny YOLO, TensorFlow Lite models, efficient date and mobile net Lite. I tested these on Raspberry Pi. So every time, so efficient date, we all know Google developed it, and it was very quantized model for edge devices, and it only had small number of parameters. So all we know the state of art object detection method is YOLO V7. So I choose YOLO V7 Tiny, which becomes very small for edge devices. And that will be a correct. Next is the TensorFlow Lite models. These are the models which are built specifically for edge devices. So so the results we tested in 4 different conditions, 4 different scenarios: normal light conditions, low light conditions, and varying the distances frame per second. So these were the litters where YOLO V7 was very good at accuracy, but what was little expensive in for FPS. So these were the result in low light conditions, high light conditions, phase and within 2 meters accuracy. We can see efficient net light and mobile net light were very good in time inference time, but they were very poor in accuracy. And then next, efficient at was very good at accuracy, but it showed a very low inference time. YOLO V7 Tiny was very good at accuracy and also FPS. So conclusion, development of TensorFlow Lite models was very good for the edge because edge devices are very memory intensive and they power intensive. So they require models which are very low in computation and accuracy with good accuracy. So these are some of the references, and thank you.
Sagar,
Yes.
can you go to your first slide?
Yes.
Yes. Okay. So which technique you have used for identification of a person?
Ma'am, simple object detection algorithm.
Which
Object detection.
huh?
Object detection algorithms like efficient and YOLO V7 tiny.
So you have used 2-3 algorithms, right?
Yes, ma'am.
Which is giving you better performance.
Like I use this on Raspberry Pi, ma'am. So on Raspberry Pi, TensorFlow Lite models were giving a better performance with comparable accuracy.
Can you show me your result once?
Right now, ma'am, a demo video I don't have, but
No, I don't want to see the demo. I want to see the output
result.
which you have received.
Okay. These were probability of a person detecting.
Move down. Sorry, move up.
With two low light and highlight, I compare.
Okay. Is there any major role of light in your this thing?
No, ma'am. We just wanted to check if these models can efficiently work.
Detect.
Low
So
light.
that's what. So light will play an important role, right, in identification.
Yes. Light will play important. Yes, ma'am.
Uh,
As we can see, with highlight accuracies are more compared to low light accuracy.
What are the limitation of your project?
Limitations is that we need to improve the like YOLO V7 because it's giving a comparable accuracy with high comparable FPS with high accuracy. So maybe we need to fine tune and then check with the YOLO V7.
Okay, thank you.
Thank you.
Okay, thank you. So next presenter is Rigzin, and the paper title is Spatiotemporal Dataset with Other Multisensory Collected Data for Human Mobility.
Hello, am I audible?
Yes, ma'am.
Is my presentation is visible to all of you?
Yes, ma'am.
Okay. Good evening, all of you. Thank you so much for giving me this opportunity. My paper title is a special temporal data set with the other multisensory collected data of human mobility. And my paper title is, okay. Oh, shit. Is this visible now? So the introduction is what we have done this particular paper. So here we have a location intelligence, which has an important function in today's world, like analyzing these location data with the combination of the sensors that lead to the rich understanding of behavior, user behavior, such as their, hello, everyone is able to see my presentation?
Yes, ma'am.
Okay. Oh, their speed, the distance they have traveled, the time they have spent in the different places. So our main aim of this data collection is to analyze location privacy so that how the user's mobility patterns can be detected. So our main aim is to collect the data and see how the data's, various data's from these applications are to be stored. So what is the value of that data is this data set can use for predict users mobility pattern and the other location related like that can be used in analysis purposes for the machine or the deep learning algorithms. Also, these multiple sensor data set is collected during indoor and outdoor positioning. For this purpose, we have used the Endro sensor app, which is the subject of the smartphone devices that we collect data from the different sensors. So why we have used this Endro sensor dataset app? As we all know, everyone is using, most of the people are using the Android phone. That's why we have chosen this Endro sensor application for the data collection purposes. Now the potential beneficiary for the data set will include the researchers who work in this domain of the pedestrian positioning, like the previously presented paper real-time data collection. They can also able to use this data set collected from the Endro sensor that is collected by us and can be analyzed their pedestrian detection. Also, they can use for the human activity classification, for the pattern recognition, as also for the location privacy. So this research make the use of variety of device sensors which allow us for the more holistic study of the various aspect of the user's everyday activity. And this may result a fascinating insight into the user's behavior, and also we can also see the evolving habits or the changing pattern of that particular user whose data is stored using the apps. The dataset also added the advantages of enabling mobile users to verify and monitor their sensor data that is being collected from the third party, which is also a source of concern. So by collecting this data, we have also inferred that how this data collection of the data from the sensors based mobile devices can be a threat to a user's privacy or the security as well. So what is the data we have collected? For this data set, we have used the Endro sensor app. It basically consists the 3,124.66 kilometer of the trajectory that is collected by the 24 users. Mostly we have done from the UIT Punjab University over a time window of the 9 months. That is from September 2018 to May 2019. That includes not only the location coordinates, date, time, altitude, etc., but the accelerometer, as we can say see the sample value of the raw data set. We can see the accelerometer, we can see the gravity from that particular sensor. That mobile phone we have in our hand are able to collect these many type variables, not only the location or not only the time or the duration of the particular users data, but also the accelerometer, gravity, their linear acceleration, their satellite in range, the time they have started, their date, their time, their sound levels, their location, altitude, latitudes, their light, their orientations, their proximity, almost 24 type of parameters they are able to store from that single application by using our simple mobile devices. So for that experimental design and the implementation, what we have done, we have just collected the 24 users data because we need a consent from that users. So we have selected 24 users over the 9 period of month. From that 24 users, only the 19 user are 19 user are able to share the data with us. That was the also the concern that when people know that your data is being going to use by someone, they are afraid to share that particular data. But unfortunately, we all have the mobile phones and we are sharing over all data to the third party unknowingly. But when we say that we want some data, then there are the users who are not want to share their data. So out of 24 users, only the 19 users are able to share the data with us. So data set contains GPS trajectory data that represents the series of the date and time points. Our basic aim was to collect the location data with the time and date, that is a spatial and the temporal data. But the device application is also storing the different other data set as well. The data set almost contains the 41,51,237 trajectories, and the total distance is approximately 3,125.24.66 kilometer, and the total time is approximately 389 plus hours. So for that, we have used the EndroSensor application and record that data for the sensors into the CSV format. So the main aim was the collection of the location data. However, the volunteers have a choice. If they want to record the others' data, they can also store and give us. So what is the data? So this is the previous slide. We have shown that 24 attributes are collected from the EndroSensor application by using the user's mobile phone. And from that, as we want to continue our work on the latitude and longitude and the date and time scenario only, to check how the user's data is being threatened, how it can be a threat to the users by sharing this particular spatiotemporal data. So we have only taken the latitude,
Ma'am,
longitude,
sorry
date
for
and time.
the interruption. Hello.
Yes, ma'am.
Yes, but you have 1 minute left.
Okay. From this data, we have done the weekend data. Now you are able to say that as in the user one, from the user one data, we have a total of the 103,369 total number of the values of user one, from which we have a unique numbers like the latitude 43, longitude 38, and the time is 103369. And the date was 11 dates are recorded. Weekdays, there they have only recorded Sunday, Monday, Tuesday, Wednesday, Thursday, and Saturday. He or she doesn't record the data on Friday. So this was the mobility pattern of the user one. So how we are able to check whether the user one, this is the particular mobility pattern of the user. So as we know that user one, who is the user one, so we have consulted that, and we are able to know that in that particular scenario, they are traveling, they have the trajectory from sector 24 to sector 11 and the sector 20B. So there is this specification table. Specification table is the location-based service. Subject area is the location-based services we can use in the location-based services. We can use it in activity recognition. And also the data format is a CSV format only. So it is very easy to use. And for that acquisition of the data, we have used the EndroSensor data, which is used Android mobile devices. Okay, so this is the particular description of the data. We have used the Institute UIT for that particular collection. And for the latitude and longitude, we have the 30.7672 and 76.5740 of longitude. So these are the parameters of the minimum and the maximum radius parameter. And also we have given this particular data on the publicly available mobility data pattern on the repository of from
Madam,
this
can you go
DOI.
to conclusion?
Yes, ma'am. So initially, we have collected the spatiotemporal data for the analysis of the privacy of the user by using the mobility of the data. So what is the thing why we have collected? So that everyone is able to use this particular data for the study, for the mobility pattern of the mining, for the user behavior detection, can be used for the location privacy, and also used for the location suggestion or the pedestrian detection as well. So for that particular thing, we have used the Android sensor data, and this is also an opportunity and the highlight which concern a smartphone users to check and control their sensor data which is being recorded or shared by the third party. As I have told you earlier, as we have chosen, almost we have gone through with the 200 users first, but from that 200 users, only 24 users are able to concern with our concern form to share their data, but only 19 people are able to share data with us. Rest of the 5 people are not able to share because they see that their privacy may be infringed. So this is the main offer of this opportunity to this paper is to suggest people that how your mobility patterns or how your particular sensor data is captured and being shared unknowingly from the with the third party. And when they are able to know that that particular data is being shared and can be used for the analysis purposes, then they are saying that we don't want to share that data, but unfortunately in the unknowingly they are sharing their data to the third party.
Madam, can you tell me what is this privacy threat you are talking about here?
Yes, ma'am. Privacy threat, like the previous, they have a real-time pedestrian detection. Now, the pedestrian, if they are doing the pedestrian detection, so if people are going from their home to their workplace, then their workplace or their home can be detected. Maybe they will be used by the robbery as well. Okay, at that particular scenario, that particular person is not always in a home, so the robber can be go to the home and rob the things.
So how they will get the individual personal mobility data?
Ma'am, with the help of the, like I have said earlier, that why we have done this particular data collection, so that we are able to analyze and we can tell people that your mobile phone or your applications are sending your data to the third party, and third party can detect the
Have you
particular.
identified any such, how many applications you have identified which are able to detect and extract data of individual?
Yes, ma'am. One is over Google as well, ma'am. Google is also detecting, like firstly what we have done, we have just go with the satellite image. We have opened the map and see the satellite image, and by by opening
See,
over GPS we are
Google
able.
also take the image, but until you share your position with me, I will not be able to see, right?
Yes, ma'am. That is the main thing. We are unknowingly sharing our data. Like we want Uber, we want to go with the Uber. So knowingly or unknowingly, we have to enter that particular location. We have to click on the location application. So that particular location is also sharing with the Google and the sharing with the Uber websites. Like also.
Do you mean to say that this Uber are not secure? Uber and other app are not secure, and they are sharing data with any third party, and
yes, ma'am.
it may be misused
There
anytime?
was a blog. There was a news also where Uber has a activity detection. Like they are also sharing the data of the user with the third party, so that, like, if I give you an example, like if we travel
Yes,
to
yes,
some.
ma'am. So what is your conclusion? Maybe you are telling that these are privacy threat. Now, what is your model? What special research you have done in this?
Ma'am, we have collected this data from the application to check how much attributes are collected from with that data, and
Which
how that data
applications,
can be.
ma'am?
Android sensor app data application, ma'am.
So, how many applications you were able to identify?
Ma'am, actually, in the application, we have a different type of sensors. Like the audio sensors we have a location sensors we have a micro, for a sound, we have a micro uh, microphone sensors, we have a gravitational
Okay,
sensors.
okay.
Yes,
So
ma'am.
I have one last question. You had
Yes.
24 parameters. What dimension, how you reduce it down to 4 parameters?
Ma'am, I have using the simple no, I have using the simple data filtering for that. For that purpose, we have used the over Python machine learning programming.
Madam, I want to know which method you have used for identifying the most important 4 parameters. See, I have 5, maybe 10 or 20 or 100 parameters. But out
Yes,
of
ma'am.
that, how will I know that these 4 are only important? We can't do
Ma'am,
filtering. See, this filtering is like in Excel, you will go and just click and you will get
no,
it.
ma'am.
I'm not
No,
talking
ma'am.
about that.
No, ma'am. We have using the data filtering techniques such as mm, uh, actually, ma'am, I'm sorry. Right now, I'm not recalling it.
Okay, thank you.
Okay, ma'am. Okay, thank you.
Okay. Next presenter is Siva Sankar, and the paper title is Spatiotemporal Prediction in Epidemiology using Graph Convolution Network.
Hello. Good afternoon. Good evening, ma'am. Am I
Good
audible?
evening. Yes, sir.
Okay. So our topic of presentation is spatio-temporal prediction in epidemiology using graph convolution network. Our paper ID is 248. The following are our presentation topics: introduction, problem statement, proposed approach, results and evaluation, conclusion, and references. Over the past few years, infectious diseases have been a significant threat to human health throughout the history. The emergence and the spread of infectious diseases have been shaped by various factors, including the environmental changes, population growth, and human behaviors. Now, following the diagram given here, for the past decade, we have experienced more prominent outbreak and epidemics and pandemics for the past century, and the most recent one is of COVID-19. Now, in recent years, advances in medical technology and public health initiatives have reduced the impact of many infectious diseases. Like the use of AI in the fight against the infectious diseases, we can forecast and prevent our diseases by forecasting, by modeling the outbreak, surveillance, and early warning and alert to the people about the disease upcoming, and treatment and drug research for each disease, and the emergency operations and response for optimizing the medical resource match and analyzing using the AI-based diagnostics, and prevention of the infection spread by self-quarantine, social distancing, preventing spread, like etc. Now, our problem statement is that epidemiological forecasting allows us to estimate the infectious diseases behavior with an acceptable degree of uncertainty by establishing when and under which countries can expect the peaks and reduction of the new cases. The spatial temporal prediction in epidemiology refers to the process of predicting the spread and evolution of infectious diseases over the space and time. In our proposed project, enables us to forecast the deaths due to the COVID-19 in 1 month's future time and based on the spatial temporal data. Now, coming to our proposed approach. Now, the first step of data workflow is data acquisition. We collect the data from the trusted sources. The data sets we are used are raw population data, flight travel data, and process features of user country COVID data. Once that completed, data has to be processed to remove unwanted attributes and filter out to the required process data. Next is the data to graph conversion step. In this step, since the proposed model is in GCN, only graph inputs can be given and not numerical Therefore, the process data is used to construct graph data using PyTorch and geometry library. Now, and this graphical data is then fed to the model for the training purposes, which is represented in our architectural form. Now, moving to our performance evaluation, the metrics used, the dataset we have used is from the Johns Hopkins University, which provided the COVID-19 statistics from the Bureau of Transportation Statistics, provide the information about all the domestic flights, include the origin and destination sites and the departure date. And the other metrics used are the mean absolute error and the root mean square. The mean absolute error, that is MAE, it is measure of the discrepancy between the actual and predicted value. They calculated by averaging the absolute difference between predicted and actual values. MAE is resilient to outliers, and the root mean square is a statistical tool that measures the average amount of errors in a group of forecasts, measuring the square root of the average of square discrepancies between the predicted and actual values. RMSE provides a more complete picture of the model's performance because it considers both the magnitude and direction of the errors. Now, coming to our result, the following are our baseline results that compares the actual output with the predicted output with different baseline models. First, the SARIMAX comes closer to the actual data because the graph of the actual data is almost overlapped with the predicted results of the SARIMAX baseline model. Then we compare the actual data with the different models like Prophet, XGBoost, and neural network as shown in the slide. Next, we are going to talk about the result from comparing the MAE and RMSE values of the baseline model represented before the previous slide with the GCN model. From this image, it is evident that the GCN model proposes the lowest mean absolute error and the root mean square error values. That is, the lower the root mean square values, the higher the accuracy of the model. The SARIMAX is next behind the GCN considering the accuracy, like then Prophet and ANN, then XGBoost likewise. Now, for concluding our presentation, in this work, we have developed a graph neural network based approach for COVID-19 forecasting with spatio-temporal data. Our model does not rely with the assumption for underlying the diseases, dynamics, and learns from varied data, including the inter-region interaction. Overall, the GCN provides a powerful tool for modeling complex spatial temporal data in epidemiology and have the potential to improve our understanding of how infectious diseases spread and evolve over time and space. These are our references. Thank you.
From where you collected data?
Any queries? We have collected data from Johns Hopkins University, which provides the COVID-19 strategy.
What are the parameters you have considered?
Like the flight frequency, flight frequency metrics, the distance metrics, and the process features of US country COVID data.
What was the data size?
Data size was it's almost a 1 year's data size, so it, for more than 1,000 queries for each CSV file. So obviously more for high size data.
So only 3-4 parameters you've used for your study?
That's
can you show me the data? Can you show me the data set?
Data set. It's not available in local system. It's in cloud.
So I'm not able to understand like what have you mentioned somewhere listed the parameters?
Yes, ma'am. In this data workflow, we have shown the necessary process data from the data graph. The flight frequency metrics, that means the flight which has traveled from the US to other regions, the number of flights between them, and the distance between each nodes between the cities, and the process features of US country. So the people who have got the diseases and are possible to got diseases. With this data, we have specified.
Can you move down to your graphs?
Yes, ma'am.
Can you explain this 4-graph interpretation?
Okay, ma'am. This XGBoost first year First we have done with Sari Max. Sari Max, we have predicted the orange line is our predicted model, and the blue line is our actual model for Sari Max.
So it should be very clearly stated in the graph. Okay. See, if you won't.
But I have okay, ma'am.
Okay, so
the
even
blue
in
line shows the
paper,
Sari Max.
In paper
yes,
also you have to clearly mention that what is the orange line, what is the blue line, what is the
it's
okay.
Okay, ma'am. Okay.
Okay, move down. Okay, so here can you explain the table?
The table, first we have compared all the models to the mean absolute error and the root mean square values for the baseline models which are represented above. From this image, it is evident that the GCN is having the lowest RMSE and MAE value from all the other models that you have compared. And the next step, it's Sari Max, which is just close to a GCN, and then Profit, then ANN, and then XGBoost. That's here compared and then represent that GCN is a better model for a consideration.
How your model is better than any other benchmark model?
I think the other models have considered for mostly on Sari Max Profit. And then
what is the limitation of your work?
Because in GCN we have chosen for time and space. For models for GCN we have used the time and space. With that we can consider for the accuracy, we can consider significant increase in our accuracy.
Okay. Can you tell me what are the limitation of your work?
Limitation means it can be only for 1 year. The prediction can be by extending the time horizon for long prediction. For the current current proposal, it's only for 1 year. For expanding it, we could extend it by long-term prediction, and also we can incorporate other diseases like polio, like that. Now we have only considered COVID-19.
Have you checked the accuracy of your best model?
Yes, ma'am. It's 90 by checking at the error rate we can show now. It's from least error, so it's up. So it's the most efficient method from now.
Okay, thank you.
As of okay.
Okay, thank you. So all the presentations are done in this session. So thank you so much. I sincerely thank the all authors for their excellent presentation and the contribution in this session. I hope this session was informative enough to all. On behalf of the whole team, thank you for the support during this 7th version and the previous 6th version of this conference. And we will be happy to have you in 8th version in 2024. So all the presenter would be getting their digital certificates through the mail within 2 working days. And already forwarded to the paper to the spincher. And the publication will be live within 6 months. So kindly cooperate with the team of ICTIS 2023. And I would like to thank our session chair for chairing the session. Here is the token of appreciation on behalf of Global Knowledge Research Foundation and the team of ICTIS 2023. So thank you for the valuable presence and knowledge.
Thank you, Riddhi.
Yes, ma'am. So last, I request to all, please turn on your camera to keep snapshot of this virtual conference. Yes. Thank you so much, and all the best for the future work.
Thank you. Thank you.